Right, good evening everybody. Thank you for inviting me here. I've never been on a stage with a flashing reindeer and tinsel and balloons before, so this is a bit of a different experience. My name's Ewan Slater and I want to talk to you tonight about the FN project. So I was going to do an introduction to serverless, but I really don't think I need to do that since you did that bit so well for me. I'm going to talk a little bit about the ups and downs of serverless, why I think you should at least consider an open source serverless platform when you're choosing your platform. And then I'm going to talk about the FN project, which is an open source serverless platform that I contribute to. It's not actually my day job, it's just something I do on the side. And we'll have a quick overview, look at some function development and look at some orchestration. So, serverless. Yes. This is actually my favourite definition of serverless because I think it captures the essence of it in a single tweet. You know, I want the burger. I want the burger, but I don't actually want to go through the hassle and the mess of killing the cow. I don't want to build a kitchen and I don't want to do the washing up afterwards. And what serverless lets us do is get access to the good stuff without having to put up with all of the mess and the pain. Now, the CNCF definition is this, and I've put the words in bold that I really care about. So, serverless computing refers to the concept of building and running applications that do not require server management. And it describes a deployment model where we're going to build functions. Our application bundles the functions, we upload them to a platform, and they are executed and they're scaled and they're run when we need them on demand and not otherwise. And this allows us to focus on the thing that the business really wants us to do, which is whatever it is that delivers value for our end users and customers. So it's increased developer productivity by adding another layer of abstraction. Has anybody ever heard anything like that before? Good God, where have you been? So Berkeley did a report earlier this year. If you haven't read it, I would suggest reading it, but they said serverless, people have been attracted to serverless computing, and particularly to functions, because it's a new general purpose compute abstraction that promises to be the future of cloud computing. Wow. Let me explain. So, this was my mother's phone for many years. We got her one of these. What does my mum do with a smartphone?
Photos.
No. No. She makes calls and she sends text messages. Does she install any apps? No. What does she do after she's made a call? Yes, exactly. Exactly. So, it's like, how long does my mum's phone go on a single charge? Probably about 3 months. She turns it on, she phones and then leaves a voicemail and then turns it off. So now she's got a new Nokia. And this is what we as an industry have largely done with cloud since its inception, is we've taken old applications and we've put them on the cloud, or we've built new applications, but they essentially look like the old applications. Here, we've not built this. We've not built something that takes advantage of the capabilities of the platform. And with serverless, that's what we're starting to do. And the result is people start to see improved programming productivity, and they start to enjoy cost savings as well, which is really nice. So, the upsides of serverless: it should make development easier because we're writing small functions, they should be easy to write, they should be easier to get right. We should improve developer productivity. And if we can do that, we should be able to be more agile as developers. And these days, the agility of the development team is critical to the agility of the business in most cases. And we should also be able to reduce our costs both in terms of development and in terms of operations. There are no silver bullets. There are only double-edged swords. So if there are upsides, there have to be downsides. Right, downsides. The number one downside I see at the moment is this. It's shiny. You know what I mean by shiny? It's the new thing. Everybody wants to do it. Have you ever heard of CV++ programming? Yeah, it's what do I want on my CV for my next job? Ooh, serverless. What were you writing? Oh, just like a bit of batch processing. Right, move on. So people will, that's the cynical view. The other view is that it's a new technology. People will push it into new realms and they'll find where it works and where it doesn't, and where it doesn't, some of them will go, ooh, serverless is terrible because it didn't work for me. Ball of mud. Anybody come across the ball of mud anti-pattern? Right. Have you ever had a scenario where somebody goes to you, I took my monolith and I split it into 5 microservices and I have to deploy all of them together? Right. So you've taken the benefit of the monolith, which was a single block, it was relatively easy to manage, turned it into 5 things, but you've kept all the internal couplings. It's a ball of mud. Now, your monolith might have gone to 5 microservices. You could also refactor it into 50 or maybe 500 different functions. And now just imagine how much coupling and pain you can create there. Yeah, ball of mud plus. The other one is lock-in. So you may find that if you build stuff on one one serverless platform, and you try and take the same function and run it on another one, it doesn't work. They're all a bit different, and you're going to have to retest them. You may also find that your choice in terms of language is a bit restricted, or you might just find that the serverless platform you're working with is too prescriptive or too opinionated. You don't really like it that way. So in a sense, when you're choosing a serverless platform, you're choosing a gilded cage. It might be a really nice cage. You might say to your friends, "Cool, look at my cage." But I think you need to be really, really sure about how happy you are going to be in that cage long term before you get in it and shut the door. Now, lock-in. What actually is lock-in? You know Burning Monk, obviously. This is one of the, he's a guy called Yang Kui. He's big onto AWS Lambda, well worth following on Twitter at the Burning Monk. But he says there's no such thing as lock-in, only switching costs. To which I say, fair enough. How big are the switching costs? You know, if all you did was you wrote Hello World on Google, and then you decide to rewrite Hello World on AWS Lambda, it's probably not that big a cost. If you rewrote, a mission-critical system and it's 250 or 2,000 functions, that might be a more significant switching cost. So, lock-in, switching costs. I think we also need to consider the dimension of risk, because it's not only what does it cost me to switch, it's how likely am I going to want to switch. So it's like that. And what are the scenarios which might lead you to switching? Well, one of the common ones that people talk about is this one, which is that your provider decides now that you are locked in, they're going to jack the price up by 10,000%. It's a risk. I'm not sure how realistic it is, because actually if you look across all the cloud providers, it tends to be they cut prices over time. Yes, rather than putting them up. So while this is a risk, I don't think it's necessarily a significant one. This one, I think, is considerably more scary. It's called the green-eyed monster. Jealousy. Your platform provider decides that they're jealous of you, or they simply want to do what it is that you do as a business. So you're coming into work one day and your platform provider, say you work for a bank, and your platform provider goes, "Oh yeah, we've just got a banking license." How happy are you about having your mission critical stuff running on their platform now, and you can't easily take it and move it elsewhere? eggs, baskets. I was talking with a software development company last week who are currently maintaining different code bases, slightly different code bases for Google Cloud, AWS, and for Amazon. And they don't like that. I know other people who go, well, all clouds have outages. They will do. I would like to spread my risk across multiple different clouds. There are some people who have or believe, they've either got a policy restriction or a legal restriction against using particular clouds. Some are not happy with the governments that might regulate a particular cloud. I mean, you could easily imagine a scenario where an American company might have a problem using Alibaba's cloud. And it might seem a little bit tinfoil hat, but I have worked with people over the past 2 or 3 years who've got all of these problems. So, it's people who want freedom to choose the languages they want. They want freedom in how to do packaging. They want to be able to do local testing. They want portability. They want to get away from different code streams. They want to be able to work across multiple clouds. They want a decentralized model, and they want to be able to choose what privacy jurisdiction they're operating under. So I think what they really want us to do is to free the functions. Now, what does freedom mean in terms of software? Ultimately, it's this. Ultimately, it's the ability to turn around to your provider and tell them to fork off. You're going to create your own version of the code and maintain it. I know some people who are prepared to do that. And so I think at the very least, you should consider an open source serverless platform when you're choosing one. You may decide you don't need those freedoms, they don't matter to you. But you might, on the other hand, decide it could be quite handy to have. Now for me, personally, the thing that brought me, or set me on the path that's brought me here tonight is language. Because my favourite development language is Ruby. Now, it's better than it was 2-3 years ago, but when I started looking at serverless, support for Ruby was pretty woeful. And one of the few platforms that regarded Ruby as a first-class citizen was the FN project. And it's not just Ruby that's the problem. Well, Ruby's not a problem, lack of support for it. But what if you wanted to write in Fortran? Yeah? There are still people who write in Fortran. If you go to the scientific computing world, you will meet lots of people who are doing stuff with Fortran, because it's really good for doing certain things. Or people who want to use Rust or Erlang. You want your choice of language on the cloud. And that's basically where we came to, or where I came to. I said, I think you want choice. You want to be able to write your functions in any language you choose, and you want to be able to run them any way that you want. And the basic idea with the FN project is that you can write your functions in any language, as long as you can run that language in a Docker container. And you can run them in any environment, as long as that environment supports Docker. And that's a pretty broad piece to play on. So, what is it? It's an open source serverless compute platform. You can deploy it to any cloud or on premises, assuming it supports Docker. It's all based around containers. It's an active project. There's a lot of commits. There's over 75 contributors, including me. We have native support for cloud events. We're sponsored by Oracle, but we're independently governed with representation at CNCF. We're part of the CNCF landscape. And we have our own language-based workflow mechanism called Flow. And the idea is that we are essentially going to package your function up as a container. So you have the function, all its dependencies. It's put into a Docker image that has a single purpose, which is to run the function. It's self-contained. The function within should be stateless. If you need to write state, you need to write it to somewhere externally, ideally using a REST API, because you should assume that the second invocation or other invocations will not hit the same function instance. Because it's ephemeral. It's going to run on demand and then it's going to go away. So what we have in the fn function is a small chunk of code wrapped into a container image. It gets its input from HTTP stream, which is HTTP over Unix sockets. And it writes it back the same way and sends the logs to syslog. So here is hello world as an fn function. So we require the FDK, that's the function development kit, and then you've got your function. There's the context, which is metadata around the call. There's the input, and in this case we see if the input's got a name field in it, and if it has, we say hello name, and if it doesn't, we say hello world. And then we call the handle method to the FDK. So, doing the installation and setting your first function. So if you're on Mac, it's actually pretty easy. You just do install. And in this case, it will tell me I've already got it installed. You can do that, or if you go to fnproject.io and you go to the Quick Start Guide, come down, and if you're on Linux, you just run that command there. Windows, I haven't installed the CLI for. But having installed that, okay. Now Slater has to type with one hand. This is dodgy. Okay. If we want to create a function, and just to show bias, let's do it in Node. See, just to say, ooh, I can't deal with that. Okay, so we do fn init minus runtime, whichever one you choose, node, and let's give it a name. Gerard? Yeah. So what that will do then, if we look, that's created a directory, and within that directory we've got our function. And we get func.js, which is the actual function itself. And we also, because it's cloud native, I don't know if you knew, but to do anything cloud native, you've got to have a YAML file. Those are the rules. So we've got a func.yaml file. And that just says that, you know, this is the function name, this is the entry point that we're going to run with the Docker container, that's the version that will get bumped when we do the build. And we also need an app. Okay, let's create app Harris. And then we can do fn deploy. So what's happening now is we're doing a multi-stage build of the container, and then we're going to push it to the registry, which in this case is Docker Hub, but you can also use a private registry, or if you don't want to have it actually doing the interactions, you can just do -- local, and it will just stick it on your local machine. So then, I can't do this. Sorry, mate. Then invoke that, and then that'll run that. So if you want to start playing with this, it's really easy. It's just a quick download, and then you can actually start using the CLI. Within the CLI, you'll find that you can start to use abbreviations. So instead of FNLS apps, you can go FNLSA, but to start with, I would recommend using the verbose mode, because it makes more sense when you're thinking about it. So that's the first function. Egg, and now, okay, yep. So, as I say, you've got the CLI, you can do fn init, you specify which runtime you want, you can deploy within an application, you can do the invoke, you can also do curl to this really nice memorable URL, which you'll get one of that sort for each kind of function that you do. So as I say, what happens at the deploy is we do a multi-stage build of the container, we actually bump the version within the file, we push the container to the registry, and we create or update our function endpoints. Function development kits. They make it a lot easier for you to create your functions. So as a developer, what you do is you include the package or library or gem or whatever it is that your language calls that kind of thing, and then you develop against that interface. The FDK is responsible for providing the input to your function, sending the output back to the person who invoked it, and also writing any errors to syslog. Now, out of the box, we have FDKs for Python, which might be hidden behind the Christmas tree, Ruby, Java, Go, Node, and .NET Core. And this is where I got hit with a boomerang. One lesson I've learned out of this is never make a suggestion to somebody on an open source project, because it starts out as an email exchange and then very rapidly descends into you write the code and send us a pull request, which I did. And then the bloke who was leading on the Ruby FDK decided he didn't want to do it anymore, and I have now wound up with that responsibility. So I'm the lead maintainer of the Ruby FDK, and the way the FDK works is that when the function container comes up, it opens a socket inside the container. The FN server connects to that, sends the payload over. The FDK then parses that off HTTP stream, and it executes the function, providing it with the input and the context, sends the output back, and writes any logs that are needed. Oops. Now, if you don't have an FDK, or there is not an FDK for your language, that is not a problem, because this is all Docker based. So you can either bring your own Docker file, or you can use a pre-existing Docker image. So let me just show you how that works. Okay. Right, easiest way here might be Bitbucket. So what I'm doing here is I've got a function. We might see some Shakespearean comedy later, but basically we build this this function off comedy base, and we add in the funcrb that's in there, and we say our command is Ruby run funcrb. And the comedy base image, so that's the init image. You create an init image, you put basically everything that you want goes into init.tar, so it includes the Docker file and the funcrb in this case, and funcinit.yaml, and you build it all with Docker file in it. And the reason I did that for this project is that I have a whole bunch of functions here, like this one. So this is, we're going to add a character to the stage, which in this case is actually KV store. And we require this helper code. And as I started to write this application, I found out that all of the functions needed access to the helper code. So I started out copying it around, and I thought, well, that's not actually a clever idea. So what I did was I came up with a single template, which gives me the base image, and then I used that as the base for all the subsequent functions. So if you have, instead of doing fn init minus minus a runtime, if you have a Docker file in a directory and you run fn init, fn will go, okay, you want to base your function on that Docker file, and then it will use that Docker file to build the function. So we also have an idea that we call hot wrap. So you might have a program that runs from the CLI, or you might decide to actually create a CLI program. And what hot wrap does is effectively acts as a shim or a surround for those functions. So if you have a program that takes standard in, writes back on standard out, what you do is you include the hot wrap binary in the Docker file, and then you make that your entry point, and then you can call that function, or you can deploy that, you can call it a function, and hot wrap will take care of providing the input to the command line application and sending its output back to you. So we can just demo that as well. So you've got this is the command that you would actually run from the command line. In this case, it's going to do a line count, and you install the hot wrap binary into your Docker file, and then you just wrap the command by making the hot wrap the entry point. Now, have I got that deployed? No, maybe I'll just do that. So if I do. So, yeah, it takes that, it tells us we've got 3 lines, and if we check the file, we've already got 3 lines. So if you've got existing programs that you want to take functionalize, this is an easy way to do it. So, from hot wrap to hot functions. So I said that our functions were ephemeral and they ran once. I kind of lied. Actually, they run at least once, and the reason for this is that if you're getting repeated invocations of the same function, you don't necessarily want to be spinning up a new container every single time. So what happens is that once the function has run, there is an idle timeout. There's a wait before it's terminated. That is a default 30 seconds. You can configure it up, you can configure it down, and that means our functions are potentially reusable. So as an FDK designer, that means you actually have to be able to have multiple invocations of the same function, and that was actually where I first got involved with the Ruby FDK. And it's another good reason to make sure that your functions are genuinely stateless, because while you can't, or you shouldn't be trying to rely on the fact that something could be written to the container, you shouldn't be leaving the container dirty either. So don't write any state to container. Endpoints. When we do an fn deploy, it creates the default endpoint, which is used by the CLI, and It's not terribly readable, it's not terribly memorable, and you only get one of them per function deployment. So what you can also do is create something called triggers, which will give you more meaningful URLs, and you can also have multiple endpoints. So you might have a different URL for internal users and external users, and you can then protect those differently. You can either create triggers from the CLI on the fly, or you can specify them in the func.yaml, or when you actually do the FN init, you can specify ---- trigger, and you can create a trigger and you can define what your endpoints are going to be that way. Now, FN server. This is like our API gateway. So it manages apps and functions, and if we were to start the project again, we would probably call the app the namespace because it's just actually a group of functions. The FN server handles the function invocations. It itself runs as a container, and it hosts the function containers inside itself using Docker and Docker. There's a couple of reasons for that. First one, in the early days, was it meant that if the FN server crashed, then it didn't do any damage to the surrounding environment. More importantly, it gives us Docker version independence, so we can have different versions of Docker running inside the FN server and outside. The architecture looks more or less like this. In fact, the minimalist architecture is ignore the green line. Yeah, so you can run it on your laptop. You just run FN start or FN start -d if you want to put it in the background. It'll pop you up a message saying you shouldn't do this in production because it expects to be on Kubernetes these days. But you have your function container that's hosted within the FN server, that's running inside Docker and orchestrated by Kubernetes. You've got your container registry where your containers live. There's a metadata store which maintains things like what the endpoints are, and there's the syslog service for logging. So when we get a request, it comes in, hits the FN server, and the FN server will say, well, for this function, do I have a running container? And is it available to do work? And if the answer is yes, then it just gives the input and the context to that. If it isn't, it will spin a new one up, and if necessary, it will go and get one from the container registry. It'll execute it, send the output back to the caller, and do any updates to the metadata store, and write any logs to syslog. Deployment. In the early days, we weren't sure Kubernetes was going to win the container wars, so at that point we actually maintained our own load balancer. These days we pretty much assume Kubernetes as the standard, so you would be deploying on Kubernetes. There is a Helm chart as part of the project you can use to do that, and you can then deploy it to any cloud, a red cloud or a blue cloud or on-premises, or even to an Antarctic research ship, because I've got a friend who works for the British Antarctic Survey, and believe me, if you're on that ship in the Southern Ocean in the winter, you don't want to be trying to interact with a cloud. It's really not good. If you're deploying onto the Oracle Cloud, it's available as a managed service, and that in the background is again running on Kubernetes. You've got your different FN servers running within the pods. And if you want to take it as the managed service, that's available as Oracle Functions. So again, you don't have to do any work, and you get your first 2 million invocations a month are free. Orchestration. Right, we've said that the functions are by and large going to be simple. They're going to run for a short period of time. So how much meaningful business work are you going to be able to do with a single function? So we believe there's a need to do orchestration. And so we have a promises-based orchestration mechanism called Flow. You may or may not be pleased to know that you don't have to learn any new special language or dialect of YAML or XML. It just uses conventional code. It's composable. You can compose the functions together. It's flexible. You can do sort of fan-ins, fan-outs, run stuff in parallel, in series, synchronously or asynchronously. So you write your flow in your chosen programming language. You write it as a function, and it's deployed as a function within an app. Now, here I would urge you to exercise a little bit of discipline, because you could, if you wanted to, start putting business logic in there. I think that's like getting this gentleman to play an instrument. Yeah? There is a reason there's a conductor and there's the instrumentalist in the orchestra, and that's a good separation to maintain. So just keep your orchestration in the flow and have the actual work being done by the functions it calls. So, time for Shakespeare. So, not long. So this is William Shakespeare's As You Like It as an FN function. So we have a bunch of characters here. There's Rosalind and Celia. They're nice girls. They've been taken prisoner by Celia's dad, who is Rosalind's uncle. He's evil. Orlando is a nice boy who turns up at court he wants to make some money, so he decides to wrestle for his fortune. Oliver, he's not so nice. He's Orlando's brother. He causes things to kick off. And then there's some other sort of minor characters. What we do is, and this is a serial flow, we create the futures, and then in each case we're invoking the function, so it's then run, then run, then run, then run, then run, then run. So it's a little artificial because it's a play, but everything kind of happens in series. So at the end of it, we get to, they all get married. They all get married, and it's lovely and romantic, and they live happily ever after. So let's see if we can make that happen. Okay. Right. Then I might shorten the other bit. Okay. That should trump through, and they should all get married in a second. We'll come back to that in a sec. Other things that we could do with this is we could do a Saga Pattern. So if you've got multiple calls to different services and you want to have some kind of transactional integrity, but you can't use something like XA or two-phase commit, you can have compensating steps. So we can use it to act as a travel agent. So if you book your flight, if that fails, you'll cancel, and if otherwise, you book the hotel. So you go on and you can create code that looks something like this. So we've got a flight future, a hotel future, a car future, and then we can compose these together. And if any of these stages fails, then we're going to cancel everything, and if it doesn't, we'll get an email to say that we're going on our holidays. So in summary, serverless gives us greater simplicity, greater developer productivity, lower costs. I think in many ways it's going to be the future of cloud computing, or actually just the future of computing. As I was saying to one of the guys before the talk started, I've just been doing some work with a startup organisation who are looking to move from a successful minimum viable product that's a monolith to scaling out and hosting on cloud. It has been immensely useful to them that they followed really good coding practices when they built that monolith. So within it, it has strong modularity. There are internal service interfaces, and that's made it easy for us to split that out into functions and microservices because those dividing lines between concerns were already there. But I think you should choose your platform with care. I think you should consider open source for the freedoms it offers. The FN project is a serverless platform, it's open source, it's portable, it's language agnostic, it has multiple FDKs. Feedback and contributions are welcome. My name is Ewan Slater. You can learn more about FN at fnproject.io. There's a Slack channel, or you can contribute at GitHub. Thank you very much. I'll just see if they get married.